Hey everyone, I'm here with Mick, the founder and CEO of Mainframe. Can you tell me what Mainframe is trying to do?
Yeah, so ultimately we're building a decentralized communications network that's censorship resistant and surveillance resistant. And at the heart of it, you have a network of nodes who are incentivized through mainframe tokens to relay and route and deliver data packets or messages in the more generic sense. And we've been working on communication protocols for almost 5 years now. We have a lot of
Wow.
experience here, and we're going to make it happen. Unstoppable communication.
So the application for this is a protocol for secure communications. So in terms of what can be built on top of it, what are some examples of apps that can be built on top of this?
Yeah, so when we started, we got into this whole world of decentralized messaging protocols because we actually wanted to replace email. So we initially
Okay.
started building an email application, and we became so frustrated with the underlying protocols, IMAP and SMTP. And that's when ultimately we said, you know what, there's got to be a better way. So we basically said, let's just rip it out from the foundation, from the root, from the guts. And that's what led us on this journey. And when we were building these decentralized messaging protocols, we were not thinking about blockchain technology at all. But what we found was that similar to email today, people who use email are trusting, basically three services: Google, Apple, Microsoft. I think 80% of all email goes through those services.
Hmm.
People were relying on mainframe, us, our hosted version for mainframe communication. And there was not a lot of economic incentive for people to kind of help support this network because the protocols were decentralized. There could be mainframe servers, but there was just no incentivization layer. And that's really what brought us to blockchain technology. But to answer your question, sorry, I just wanted to give a little bit of background. But to answer your question, I mean, at the heart of it, it's a peer-to-peer network, and data packets are moving all around this network. And so a lot of our experience is in messaging and in communication, but that's not to say those are the only applications that can be built on the mainframe network. I mean, there's a physician out of Stanford Hospital, and he's talking about how they just have no communication tools that are both HIPAA compliant to preserve kind of that privacy for their patients and that work for them. And so there's just a perfect use case where it's like there's a hospital in the medical, records industry being able to communicate in a secure and private way. That's one use case. I mean, obviously, we built the first application on the network. It's called Onyx. It's a Slack-like messaging tool. We gave a presentation at DevCon in Mexico at the big Ethereum Foundation developer conference. And so you can have kind of a Slack-like application built on it. I mean, obviously, you can have kind of a HIPAA-compliant record-sharing application, but you could have a decentralized Twitter built on our network. You could have a decentralized Reddit built on our network. You could have a decentralized social network built on our network like Facebook. So there's a lot of different applications that could be built on our network, but a lot of it, because our technology is, you know, compelling in terms of the censorship resistance, its surveillance resistance, I would think a lot of things around communication and media would be great use cases.
So you had this idea going forward, and you started this like 5 years ago. That's a long time ago, and you are using blockchain technology to solve the root problem, which is how do you encourage more nodes, more participants in the network? Because that's really what the incentive layer, incentivization that blockchain can bring as well.
Exactly. We're not building a new blockchain. It's a peer-to-peer network, but we're leveraging blockchain technology for the incentivization layer. And really, I mean, to us, that's so compelling about blockchain technology. So.
Right, and recently I read that in the Russian courts they were trying to force Telegram to give them their private keys, the keys to unlock all the messages, because the Russian government wanted to maybe have surveillance on a few individuals. So how can Mainframe solve this problem?
This is one of the fundamental problems around centralized communication tools, right? So even though that they might, supposedly they're encrypted, there are always these backdoors, and there are always these ways in which the centralized authority will be able to, or will be forced to, reveal some of the data or some of the contents of those messages. So encryption to us is really just one aspect of privacy and security. So really what Mainframe I would say one of the more compelling features of Mainframe is this feature called dark routing. So on traditional peer-to-peer networks, even if the data is encrypted, you could still see which nodes are speaking with what other nodes. This is sort of the Edward Snowden stuff where it's like metadata. These governments can glean all this metadata of who's talking to who. With Mainframe, essentially you have dark routing. And so you wouldn't be able to see who is speaking with whom. We're using this feature called luminosity, where when you're addressing somebody, you can kind of specify how how specific you want to be, or how generic you want to be. And essentially you're able to say, instead of it going to a specific address, let's say you're sending a piece of mail, you could put a zip code and the house address all the way down to the specific door number. Or with the mainframe network, essentially you could say, I want to send this to New York. And obviously there's topic IDs, and we can get into all the specifics, but essentially it'll get pinged to all the different nodes in that whole region. And so anybody who's observing that traffic would not be able to see who you're speaking to. And essentially that makes it harder to disrupt, denial of service attacks. So that makes it a lot more unstoppable. Is this sort of, not only is it decentralized, not only is it incentivized, which would make a stronger decentralized network, but it's also dark. Anybody who's watching this network will not be able to see who is speaking with whom. And so not only censorship resistant, but surveillance resistant. And so the layer, the level of privacy and security that this network provides is simply unprecedented.
That's awesome. So it's really something that's never been done before, because what you're saying is that even traditional networks messaging platforms, they still rely on centralized relay servers. So technically the government can snoop in and figure out who or where I'm talking to. So they might not know what's being said, but they can still track it. There's still surveillance. Yeah, exactly. And also they can potentially disrupt that communication as well.
Yeah, I mean, Brazil banned the app WhatsApp, right? So all of a sudden, anybody who's using WhatsApp, I mean, that was for a short time, but this is an example of we're relying on these centralized communication tools, and it's very easy for just a judge to say, no, this is no longer allowed. Just today, Amazon sent a letter to Signal. So Signal, a lot of people use Signal for private and encrypted communication. And Amazon told Signal, no longer are you going to be able to do domain fronting. So essentially domain fronting is a way that Signal is getting around some censorship in countries like Iran, Egypt, the UAE. And no longer is Signal going to be able to kind of get around that censorship. And so Signal essentially is going to be unusable in those countries. And so, yeah, you've got these countries that, for whatever reason, we can debate that all day long, they won't allow certain communication tools to be used.
Right.
Essentially censoring that communication. And so with Mainframe, that would be impossible to do, right? I mean, it's a network of nodes, 1,000. They would essentially have to shut down the internet to shut down Mainframe.
So will the routing way solve that? Because there might be communications potentially censoring on something like a firewall like that?
The traffic on this network is completely encrypted. So they would not be able to see, what is mainframe traffic versus what is not, right? These are nodes across an entire network. There's no way for those governments to be able to see what that network traffic is. And certainly they could try to attack certain nodes, but Mainframe is hosted by thousands of nodes all over the world. There's no way that they will be able to stop it. So it's, again, a lot of it. Now, they might be able to try to stop specific applications. Maybe there's an application in the App Store that, an application that's leveraging the Mainframe network. That could be possible. But again, because it's completely open source, it would be very easy for all new applications to get sprung up very quickly. And so it would be very hard to do. But yeah, we understand. I think one of the tricky balances that we have as a company, we're not a project. We see ourselves as a company. We're trying to build a business here and to hopefully change the world with technology that can impact millions of lives. But one of the challenges that we have is this technology is open source, and it could be used for great reasons, for security and privacy, and big enterprises who are trying to make sure their trade secrets aren't hacked or leaked, et cetera. But it could also be used for malicious reasons. And I think that's one of the biggest challenges that we have to try to navigate, is how do we make sure this powerful technology can be used for good? And we're working with governments. Maybe we could even work with the government of China or the government of some of these other countries that have censorship, simply because they also have communication that needs to be private. They also have documents and collaboration that needs to be super secure from adversaries or hackers, et cetera. We believe that not only should citizens have privacy and security, but also enterprises and also governments. And so these same governments that might want to censor their citizens will be the same governments that want to leverage our technology for their own reasons, their own communication, their own privacy, their own security, et cetera. So we've got kind of this tricky balance that we're trying to walk of, we believe in freedom, we believe in privacy for citizens. That should just be a right that we all have all over the world. Um, and so in some ways, there might be some conflict with governments, but at the same time, we think governments will want to leverage our technology for their own reasons, for their own security.
Right. So let's talk about the network setup and the utility of this. So you talked about a little bit about using blockchain technology to provide the incentivization layer. So what's the mainframe token going to be used for?
Yeah. So essentially, when you're sending data across this network, it's going to be passed and routed along this network via mainframe nodes. And these nodes are not just passing data out of the goodness of their hearts. They want to get paid, right? They got mouths to feed, bills to pay. They want to get paid. And so the mainframe token essentially is used to reward and incentivize nodes on the network to help pass messages along. They could be used to help store messages because sometimes the destination node is not online. And so we have these things called delegate nodes, which essentially means that, oh, if the recipient's not online, I will hold the data packet for that node and I'm going to get paid. So nodes are paid in mainframe tokens to relay messages, to store messages, to deliver messages. And those are just a few examples of how a mainframe node gets paid. And they get paid in mainframe tokens. And so the mainframe token is essential to the mainframe network and to making sure it runs properly.
So if that's the case, does that mean if I send a message and I need to use these nodes, do I need to start paying mainframe tokens as well? So
yeah, so similar to, on Ethereum, anytime you want to send a transaction, there's a small gas price, right? Now with mainframe, hopefully, ideally, the application developers, the people who are building dApps on mainframe are abstracting that concept away from the end user. Because let's just use Slack as an example. So Slack, you've got some admin who swipes a credit card, and it's just you pay $10 per user per month or something like that. Now, there's payment required to use Slack, but the end user, the employees who are using Slack aren't swiping credit cards. They're not thinking about the cost. And so we hope that the application developers who are building on the mainframe network are not, exposing that level of granularity to the end user.
Yeah.
That should completely be hidden away. End users should not even know that mainframe tokens are used at all. It should feel like a great world-class messaging experience if it's a messaging app, I suppose. And they shouldn't even know that every message that they're sending, every data packet that's being routed across this network has a cost to it. So yes, there is a cost. It should be negligible on a per message basis, but ideally the end user doesn't even realize that exists.
Yeah, so it'll be paid by an admin or the corporation responsible. So it really depends on how it's going to structure it. Now, one question is this, all right? So now mainframe tokens are going to be used for transactions, but then it's also working on Ethereum as well, right? So
the nice thing about the mainframe network is it's standalone peer-to-peer network. It's only using the Ethereum network for the token. There needs to be a blockchain where we have kind of the settling of accounts of tokens to figure out who owes who what, who has what balance. But there's nothing specific about like that those tokens could be stored on any network, on any blockchain. Right? We're just using Ethereum because we think that's maybe the most mature right now, but we could easily move it to some other blockchain, or maybe in the future we create our own blockchain. But it's blockchain agnostic in the sense that a dApp developer on Tezos or a dApp developer on EOS if they're wanting sort of that communication or that messaging experience, they'll be able to use mainframe. So it's not only a peer-to-peer network that can be used on Ethereum, it can be used on any blockchain, completely interoperable and agnostic to blockchain.
Okay, but in terms of accounting, let's say I'm gonna route a message through, and it takes a little fraction of a mainframe token. But do I have to pay gas costs as well for that? Because now I need to transfer that and pay the nodes on the network.
Yeah, that's completely abstracted away from the end user, and that's not really even. I mean, that's not even a thing that you'll need to consider as a developer.
Right. And how did you solve that problem? Because you're still paying out people, right? So how did you solve the problem of too many transactions being generated here?
The nice thing about what we're doing is, we're not dependent, we're not constrained by blockchain scalability. So essentially you have nodes across the network and they're not getting paid in real time. It's not synchronous. In fact, it's completely asynchronous. So nodes essentially are keeping track of what node owes what other node. And essentially when they want to get paid, they can say, okay, I'm ready to get paid. Everybody pay up. but it's not dependent on kind of that transaction going through on the Ethereum blockchain. It's completely asynchronous, and so we're not constrained by scalability of Ethereum. Is Ethereum going to scale? Can we handle millions of messages being passed across the mainframe network? We're not constrained at all by some of those constraints of people who are building, right on top of Ethereum.
Is there any risks of a malicious node that would, potentially try to sabotage the network?
Yeah. So, in terms of they're not going to be able to read the contents of the message because it's completely encrypted, and unless they have the private key, they're not going to be able to encrypt the message. Mm-hmm. But we're using this protocol called this kind of incentivization protocol called swap, swear, and swindle, which essentially means, not only are they rewarded for good behavior, relaying messages, etc., mm-hmm. they will be penalized for bad behavior. So essentially, any node who wants to participate on this network will stake tokens as well.
Okay.
And if they're not living up to their duties, if their performance is poor, based on the peers around them, based on essentially other nodes being able to kind of monitor their performance, then they're going to lose their tokens. So there is kind of this carrot and stick approach where you'll get paid for doing good work, but you'll also lose your tokens if you're doing bad work.
Do you have any partners right now who's developing applications for the mainframe network?
We do, and we're really excited about some of the partners we're working with. We have not yet announced them, mm-hmm. but I will say these are big enterprise companies. I will say these are big government organizations, in fact, full-on city governments.
Right.
So we will be announcing it little by little, but mm-hmm. they're the types of people that you would expect to value this type of technology, right? These are institutions who need that extra privacy, who need that security, who need that resilience, who need control of their data, who need flexibility around the application layer and being able to kind of build the type of functionality that they need for their organization. And so, yeah, we're going to be announcing some of that very soon.
Awesome.
But these are well-respected organizations.
So at the end of the day, it could be just a complete business-to-business app. It could be a private-to-private app, but they just want the extra security there, and they want to use the mainframe network. And if they want to use it, then they can use it, and they gotta pay a little bit of mainframe tokens to in terms of getting the message across.
Yeah, I mean, this is a whole new world, right? We've got tokens. We want to build a real business here. We want to work with governments and enterprises and people who value the technology that we build, who value the services that we provide. And yeah, so, we hope to make it as easy as possible for people to build on our platform. But ultimately also we want to have a profitable and sustainable business model, right? Because if it just becomes harder if the core developers of the technology don't have a way to sustain themselves. I think technology can languish, and we hope that so many people out there will contribute and to make pull requests and to fix bugs, and we want that, and we're excited for that, and we want to build an exciting community. But we really need a strong core set of developers who are focused on this full time, because we need to continue to innovate and continue to take things to the next level. There will constantly be new threats against the technology, new threats against our privacy, and we need to continue to push it forward. So it's important that we do have a sustainable business model behind how the core developers are funded.
And in terms of delivery, when can people start using the mainframe network?
So Onyx right now, kind of the first application is live. It's working. It's decentralized. It has dark routing. We're still working on some of the incentivization piece, which will make it even further decentralized and make it even more unstoppable. So we're still working on that. But we're planning on distributing tokens, and the tokens will be usable. You'll be able to stake tokens and use Onyx and use the mainframe network. So that's very soon. I mean, that's imminent. But we're going to continue to develop it. So again, it's live, it's working, but there's so many improvements. There's so many things that we want to do and that we're going to continue to work on. So
awesome. That sounds pretty great. And I wish you guys all the best, and I hope you guys can have an update. And we'll want to see where the secure communications take us. And I'm very excited to hear what partners you guys have in mind.
Thank you so much for having me. It's an honor. And you're actually the first YouTube interview that I'm doing. So you should feel very lucky. But I feel lucky as well.
The first ever interview. That's absolutely
the first ever interview. We've been heads down. we've been trying to execute, and we'll continue to execute. And yeah, we'll go to a few events. It's sort of the dog and pony show. Sometimes I get so sick of this superficial roadshow type mentality in crypto.
Right.
We just want to build. We want to spend time with our community and build and execute. But I'm honored to be invited to be on this channel. So feel free to invite me back anytime.
Awesome. And I really want to hear some updates about what's happening and how like secure communication is, because that's actually really important to me as well. So wish you the best of luck, Mick, and fight forward. That's build that beautiful dream.
Freedom.
Awesome.
Thank you so much, Michael.